All right, this is the Unit 3 review. I'm going to take you through every single question to make sure you feel nice and comfy for your Unit 3 test. First one says it would like you to write three equivalent fractions to represent the shaded part. Always read the question entirely and note important information like when it says 3. Because if you write 1, even if you do it correctly, you still miss 3 points. Okay, so I see egg carton, right? I'm used to splitting it with strings, and so when I look at this, the first thing I do is I try to split it into 2 equal groups, which I can do by maybe laying a string across the middle. Now I've cut this in what? In half. So I have 1/2, 2 halves. How much is filled? 1/2. Okay. I can then go a step further if I lay a string across the middle. Now I've cut the egg carton into 4 pieces. That means our bottom number would be a 4, the denominator. So we're working with fourths. 1/4, 1/4, 1/4, 1/4. How many of the fourths are filled in? I have 1/4 on the bottom, 1/4 on the top left, so I would have 2/4 all together. Now I need to split it up again to get my third fraction. So maybe I will lay strings between all of the eggs. Now how many pieces do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're in twelfths now. How many of the 12 eggs are filled in? 1, 2, 3, 4, 5, 6. 6/12. There we go. So as you go through here, and you see an egg carton and it wants you to give equivalent fractions, maybe start with the largest pieces. Maybe try to break it with 1 string, and then add a string, add more strings. It'll help you visualize it as you go. As I look at B, I can think of it in a couple different ways. They want 3 fractions. Well, the first thing I'm going to do, I see green strips. Whenever I see a base 10 mat with strips on it, I always think green strips because I like that visualization. And I know that each one of these is 1/10. Now, how do I know that one strip is a tenth? Because there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 strips that make up this mat. Okay? So if I have 2 of them, I have 2 what? I have 2/10. Okay? Now, I could think of it differently, and I could think, well, 1 strip, maybe I'll write this over on the side, like 1/10 is 10/100. Ooh, how do I know that? Well, if I look at 1 green strip and I count the small squares, there are 10 of them. And then altogether, 10 times 10 is 100. So this whole mat has 100 squares, and then I have 20 of the 100 squares. So I have 20/100. Because if 1 strip is 10, 2 strips is 20. Now, this next part, I'd say, would be a little bit more of like a big brain moment. But I think we're going to figure this out because you could do, maybe keep adding zeros and you could do 20 thousandths, something like that. But there is an even smaller piece because look at this 2 and this 10. I could cut both of these numbers in half and get a fraction equivalent. What would that look like on the grid? Well, let me zoom in just a pinch so that it's a little bit more clear. If I look at both of these strips as one piece of a fraction, well, let's keep going. So I would also have this one. That's 2, 3, 4, 5. So if I think of these 2 strips as one part of a fraction, there are 5 of them. So I, in essence, have split this entire thing into fifths. And I'm just going to, real quick, because I think it's worth the visualization, I'm going to draw it in. And maybe I could use a little bit of a thicker marker here. Hopefully it doesn't bleed through the page too badly. It's just, I like to be able to visualize it. So it's almost like we're laying strings on the egg carton again, right? But if you look at that, I have 1, 2, 3, 4, 5 pieces now. Okay? How many of them are full? Well, hopefully we can look at this and go, well, there's only this section right here that's full. The other 4 are empty. So I would have 1/5 full, which is half of 2 and half of 10. Okay, half of 2 is 1, half of 10 is 5. We have a fraction equivalent. Awesome. Coolio. Now, let's move on to our next one. We know that when we're looking at a geoboard, that the entire thing represents the number 1. Okay, that's super important. Now, if I look at this, looks like they've sort of split it up into what's? 1, 2, 3, 4. Fourths. How many of the 4 are filled in? 1 of them. Okay, let's add some more rubber bands to our geoboard. Maybe I'll add 2 more. Now I still have equal pieces, I just have a different number. 1, 2, 3, 4, 5, 6, 7, 8. Oh, so I broke this up into eighths. How many of the eighths are full? 2 of them. Now what if I connect the remaining dots that I haven't connected yet? Now what have I broken it into? 16 pieces. So now I have 16 squares. How many of those squares are filled in? 4 of them. You should notice a pattern with the geoboard that's very interesting. 1/4, if you double both numbers, is 2/8. If you double both of those numbers, you get 4/16. These are all the same amount of the geoboard, but we have cut the pieces, starting with the 4th, in half, and then we cut the 8ths in half to get 16ths. James wrote this equation on his paper. Is it true? 1 5/6 is the same as 6/6 plus 5/6. Well, what is 6 out of 6? If I break something into 6 pieces, and I give you all 6 of those pieces, how much of that thing do you have? Well, you actually have 1, don't you? 1 plus 5/6. This is 1 5/6. Is it the same? Absolutely. But just in case you're not sure, let's think of it this way. Just a couple examples. If I break something into 2 pieces and I give you all of them, you have the whole thing. If I break something into 3 pieces and I give you all 3 pieces, that's one thing. If I break something into 4 pieces and I give you all 4 pieces, that's the whole thing. So it doesn't matter what the fraction is, as long as the numerator and the denominator are the same. So I could say, like, let's break something into 77 pieces, and I give you 77 of them. That is the number 1. That's just the way that works. So whenever you see something like this, 6/6, ooh, top and bottom both agree, that's the same as the number 1. Okay? Oh, it did bleed over a little bit, but that's okay. We'll try to ignore it as we go. Write 3 more equations for 1 5/6 that are true and all different. We're only going to use sixths, but what do we know? 1 5/6. Well, let's leave the 1 alone for right now. We'll leave the 1. But how could I break up this 5/6? I don't know if I'll be able to do this quickly, but I think it's worth it. I've got 1, 2, 3, 4. Got 1 more hiding in here somewhere. 5. Okay. So here's my 5/6. Okay. Maybe I'll zoom out so that we can see them a little bit better. Turn them all the right way so we can read them. Okay. Here I have 5/6. Okay. Right now, our fraction that's written down says that we have 1 5/6. Okay? That's the fraction right here. But we're going to break it apart into a little equation where we're adding stuff together. So maybe I say 1 plus 1/6 plus 4/6. I still get 1 5/6, but I've just kind of broken this 5/6 into a 1/6 and 4/6. Okay? Maybe for the next one, we're still in the exact same number, 1 5/6, but we want to split the number up differently than we did here. So maybe I split it this way, where I have 2 and 3. So I'll say my fraction is 1 plus 2/6 plus 3/6. So my numbers don't match the ones up here. These are different equations, but I still get the same answer. Now, if you want to make it like a little bit longer, I could maybe put a little gap between all of these so that they're all separate. What would that look like? I have 1 still, plus what? 1/6, 1/6, 1/6, 1/6, 2, 3, 4, plus 1/6. All of these still add up to 1 5/6. I haven't changed any of these pieces at all. I've just separated them into an equation where I have to add them together. Maybe I add 1 and 4, maybe I add 2 and 3, maybe I do 2 and 2 and 1, maybe I do 1, 1, 1, 1, 1. You can split them up however you would like. You still get the same answer. Okay? Hopefully that was helpful and worth the wait. Lindsay made 2 pizzas that were exactly the same size. She cut the first pizza into 3 equal pieces. She cut the second pizza into 6 equal pieces. She gave 2/3 to her sister and 4/6 of the second one to her mom. Cal, the little brother, says it wasn't fair because Mom got more pizza. And Lindsay said they got the exact same amount. We have to figure out who is right and who is wrong. Now, on the next page, it gives you space to write, and that's what I'm going to do because I like to draw. So I'm going to try to draw 2 pizzas that are exactly the same size. Even if it doesn't look that way, in your brain you have to tell yourself that it is. Okay? So, sister gets 2/3 of the first pizza. Okay, so that would be 1/3 and 2/3. So that's how much sister gets. Now Mom gets 4/6 of the next one. So Mom's gonna get 1, 2, 3, 4, 5. Wait, 4/6. So sister gets 2/3. Mom gets 4/6. Now Carl says it's not fair, but Lindsay says they're exactly the same amount. What do we think? It looks pretty close, doesn't it? But if you thought to yourself, well, it looks close, but how do I know? Let's compare 2/3 versus 4/6. As we look at both of these numbers, do you see a relationship? If I wanted to turn a 3 into a 6, I would have to take it times 2, right? But if you change one number, you have to do the same thing to the other, so times 2. 2 times 2 is also matches the other one, doesn't it? So if I double 2/3, I get 4/6. Now what if I cut each of these in half? What do I get? 2/3. Wow, these numbers are fraction equivalents. And I checked twice. I doubled one, but just to make sure my math was right, I cut the other one in half, and I still got it to match the other fraction. So the answer to who is right, Lindsay or Cal, sorry Cal, it wasn't unfair. They have the same amount. And we just drew it, so that problem is done. Jill ate 1/2 of a mini cake. Fran ate 1/4 of a giant cake. So let me zoom out so you can see it just a little bit better. But let's do this. So here is the mini cake, and here is the giant cake. So Jill ate 1/2 of the mini cake. and their friend and Fran ate 1/4 of a giant cake. Andrew said that Jill ate more than Fran because 1/2 is always bigger than 1/4. And do you agree with Andrew? Well, if I just look at this drawing, I can see that this half is way smaller than this 1/4. So how can that be? Because usually, like if you look at the pieces together, like let's say I have the number 1, and then I look at 4ths and halves. If I look at the number 1, and then I break it in half, well, here's a half. And then if I break those in half, I get 4ths. Well, usually 4ths are usually smaller than a half, right? Half of 1 is a half of a half is a 4th. But in this case, it doesn't quite work out. Why is that? Well, it would definitely matter because both of these cakes are not the same size. If they both had the same cake and Jill had half and Fran had a quarter, yes, Jill would have eaten a bigger piece. But the size of the objects are not the same, right? So I don't agree with Andrew, and I hope you do not either. So I'm going to write no up there and a little explanation down below. On the back here, Kara says that 3/10 of the grid below is shaded in. Ken says that 30/100 of the grid is shaded in. Who is correct? Well, I like, you know what, that I like my green highlighter. So if I look at this, I have 1, 2, 3 strips, and we know that those strips are tenths. So this would be 1/10, 1/10, 1/10. So that is 3/10. But if I count all of the squares, there's 100 on this grid. If I count all of the squares that are shaded in, there are 30 out of the 100. Right? So who is correct? Well, they both are. Why is that? Well, that you could say that 1/10 is 10/100, right? So that would mean that 3/10 is 30/100. And if you remember our rule from class, we can convert tenths to hundredths by simply adding a 0 to both numbers. Okay? So you can explain that however you want as long as your logic runs somewhere along those lines. Okay, number 6, true or false? 1/4 is larger than 1/2. Here's my half. Here's my 4th. This says 1/4 is larger than 1/2. Disagree. I'd say that's a big old false. A little fibbers. Now, if I look over here at my next one, 80 equals 8/10. Let's see if they used the rule correctly. The rule says if you want to make tenths into hundredths, you would add a 0 to both numbers. Are they the same? Yeah, so that's true. 5/10 and 40/100. Let's use the rule again. Add a 0, add a 0. Is the alligator eating the bigger number? Yes, it is. 2/4 is greater than 3/6. Ooh, interesting. This is kind of fun. Now, there's a couple ways we could do it. We could look for a common denominator, or we can just make this a little bit friendlier to think about. If I were to say, how many 2's go into this 4? So if I said this 2 and this 4, 4 divided by 2 is 2. 2 divided by 2 is 1. Okay? So my fraction equivalent for 2/4 is 1/2. If I think of the same thing over here, how many 3's can go into 6? 2 of them. How many 3's fit in 3? 1 of them. My fraction equivalent is 1/2. Oh my goodness, the alligator can't eat either number because they should be the same. That is false. If you did want to go maybe a little bit of a different route, you would say, what is a factor of 6 and 4? Well, the answer would be 12ths. And I would say, what times 4 is 12? 3. So if I take this whole thing times 3, I get 3 times 2 is 6. 3 times 4 is 12. That's 6/12. How do I turn 6 into 12? Well, I need to take the whole thing times 2. 2 times 6 is 12. 2 times 3 is 6. Ah! Both numbers are the same. A couple different ways you can find the same answer. All right, you have to tell me whether it's which one's greater, which one's less, or if they're equal. I'm going to point out something that I like to point out for every single decimal comparison, is that you always look at the green strips first, the tenths, because the tenths are the bigger number. Until you know which number has more tenths, it really doesn't matter how many hundredths there are. Because if you think of it, those green strips have 10 yellow units in them, right? So this would be like 25 hundredths, 75 hundredths, 51 hundredths, 50 hundredths, 10 hundredths, 6 tenths, that's going to be an interesting one, 80 hundredths, and 8 hundredths, okay? So let's just do a side-by-side comparison as we go through here, and hopefully this will make perfect sense. 0.25 versus 0.75. The alligator needs to eat the bigger number. Look at the greens first. Which one's bigger? The 7. This is 25 hundredths. This is 75 hundredths. 75 is way more than 25. As I look at 51 hundredths versus 50 hundredths, you can't use the first number to compare because the 5 and the 5 are the same. So then you move on to the second digit, the hundredths, and the 1 is larger, so the alligator's going to eat the larger number. This is going to trip a few people up because when you look at this, this looks like you're comparing 10 to 6, but you are not, are you? Look at the green numbers. Which one's larger? The 6's. Now, if you thought to yourself, but how do you know? Because that 10 looks pretty convincing. Well, what is this? 10 hundredths? What is this? 6 tenths? How do I make these numbers comparable? Well, if you want to turn tenths into hundredths, you need to add a 0. Now it's obvious. 60 hundredths is more than 10 hundredths. Okay, over here. Let's see, last one. 80 hundredths versus 8 hundredths. So I have 80 hundredths versus 8 hundredths. Now that seems pretty clear that this would be the larger number. You could have just looked at your first digit and gone, oh, 8's bigger, has to be that one. Oops, where did I lose that one? All right, let's write each fraction as a decimal number. Whenever you see hundredths, you know you're going to have 2 digits. 0.65. Okay. Ooh, I see tenths. I'm only going to have 1 digit, 0.7. Okay. Because we know that hundredths are the yellow units out of 100, and we know that the tenths are the green strips, which there are 10 per unit, or per mat. Okay, once again, 2 tenths. What would our green number be? Well, it would be 2 strips, 2 tenths. 89 hundredths, 0.89. Because we have hundredths, we know we're going to need 2 digits after the decimal. Alrighty, Hannah has 2/3 of a yard of blue ribbon and 9/12 of a yard of green ribbon. Which piece is longer, the blue or the green? Well, we could think of this as a couple ways, but I would like to think of making 9/12 and 2/3 agree. So maybe I want to take this 2/3 and figure out what to take it times so that I can have 12ths as the denominator. 3 times what is 12? 3 times 4 is 12. 2 times 4 is 8. So now I'm going to compare 9/12 to 8/12. Which one's larger? The 9/12, which is green. How do you know? Well, I just drew it out right here. But if you were like super curious, I could put these pieces on here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's my 9/12. See if I can make them look good for you. And then I'm going to find my 2/3. Thirds are black. Okay, here we go. Boop, boop. Oh, see? So if just by looking at these pieces and comparing them, you can actually see that 8/12 is the same as 2/3, and I have this one left over. So the 9/12 is more. Okay? 10. Ooh, here we go. 2/10 plus 46/100 make them agree. Add your zeros and then add. Okay, you can pause this video anytime you want. It actually might be helpful if you did the problem and then pressed play to check your work. Okay, I'm gonna do the whole numbers first. 5 plus 7 is 8. 7/12 and 1/12 would be 8/12. 5/9 minus 3/9. Uh-oh, I have 5 of the 9 pieces and I get rid of 3 of them. I only have 2 of them left. Okay, now another subtraction. Start by subtracting the whole numbers. 6 minus 3 is 3. Now, let's finish with our tenths. I have 7/10. I'm going to give 3 of those tenths away. I have 4 tenths left. Robin ran 6/10 of a mile yesterday. Her friend Emily ran 36/100 of a mile. Who ran farther, Robin or Emily? Well, let's take the tenths, add zeros to it, and we can see very clearly here that 60/100 is more than 36/100. So that would be Robin. Explain your answer. How do you know? Well, I would say 6/10 equals 60/100, which is more than 36/100. And I used my alligator to eat the number to prove that I'm right. How much of a mile did the 2 girls run in all? Oh, goodness. Well, if one of them ran 60/100 and the other ran 36/100, if I combine both of those top numbers, looks like I would have 96/100, almost a whole mile. 96/100 of a mile. Make sure you label it. Josh and his dad want to make 10 hamburgers for their family cookout. Josh's mom says it takes 1/2 pound of ground beef for each hamburger. So how many pounds are they going to need to buy? Well, 1 pound. Let's see. Oh, sorry. We're going to say 1/2 of a pound is 1 burger. So if I need 10, I'm probably going to have to take this half and I'm going to have to multiply it by 10 or add 1/2 10 times. But let's do the multiplication. I'm going to take 10 times 1 and I'm going to get 10. 10 times 2 is 20. Oh, excuse me. Sorry, I was like, why is my brain not seeing that? I'd like to almost think of it a different way, but that's okay. We are going to take 10 times only the top number. So that's going to be a little bit more confusing, but you'll see in a second. Because I need to do 10 half pounds, right? So that would be 10 halves of a pound. All right? Now, if we want to get fancy and figure out what that number is, because this is an improper fraction, I could say that would be 2 halves plus 2 halves plus 2 halves plus 2 halves. Am I there yet? 2, 4, 6, 8, almost. One more. 2 halves. And what do we know about each of these? That each of these 2 halves is 1, 1, 1, 1, and 1. If I add all of those ones together, what do I get? 5. So we're going to need 5 pounds. That one's a little trickier. It takes a couple steps. But to make it a little more complicated, what did Josh's dad decide? He's going to buy 6 pounds of ground beef and put the extra in the freezer. How many pounds will he have left after he and Josh make dinner at the cookout? So we know that we need 5 pounds. That was our answer. But Dad bought 6. So if we use 5 of it, well, there's only 1 pound left. Does that make sense? We needed 5 to make the 10 burgers. But Dad bought 6 pounds. He bought too much. How much would be left? 1 would be left, because 6 minus 5 is 1. Oh goodness, butcher paper time. It takes 8 2/5 feet of butcher paper to cover the bulletin board in Mr. Smith's classroom. Mr. Smith already has a piece of butcher paper that is 5 1/5 feet long. He went and got another piece that was 2 2/5 feet long. How many feet of butcher paper does Mr. Smith have in all? Well, let's take the 8 2/5 that he needs. Okay, that's what we know. That's what he needs altogether. He already has, I don't like how small that is. He already has 5 1/5, and he went out and bought 3 2/5. So we need to figure out how much he has altogether. Let's combine our whole numbers first. 5, 6, 7, 8. And now he has 2/5 plus 1/5, which is 3/5. Okay? Will there be enough? So that's feet. Oop, sorry. So we've answered this question. Oh my goodness, I just realized that you couldn't see anything that I just did. So let me quickly describe it. This is how much he had. This is how much he bought. When you combine them, you have 8 3/5 feet of butcher paper. Now, it says, will there be enough to cover the bulletin board? Explain. Well, he needs 8 2/5. He has now 8 3/5. We know that 8 3/5 is more than what he needs. So yeah, so he has enough. Yes, and our explanation is right there. Woo, that was a lot of pages, and I applaud you for your patience. I highly recommend that you take a look at anything that didn't quite make sense and see if you can do it independently without any extra help, and then practice that maybe a few times until you feel really comfortable with it. Good luck with your test. Ask a Math Wizard for help if you have questions.